Let me start with the question. What is the difference between these two systems? Well, most likely one of them will make you lose a couple of friends. But there is also a fundamental difference between these two systems. In fact, the one on the right is a deterministic system, while the one on the left is a random system. This means that the one on the right evolves according to a set of well-defined rules, in this case, the laws of gravitation. And so if we know the current position of the planets, we can predict their positions after a certain amount of time. In practice, this means that we can predict the position of Mars for the next week. On the other hand, we have a board game with an intrinsic random component, in this case, throwing dice. This means that we cannot predict how is the board going to look like after the first turn, making predictions for the 10th turn impossible. But these systems share a surprising property, and believe it or not, that's what I'm interested in studying. Even though we can predict the positions of the planets for the next year, if we ask the very same question over the next billion years, then the answer is not so clear. The solar system exhibits what we call a chaotic behavior. Edward Lorenz referred to this as the butterfly effect. Small errors on the measurement of the positions of the planets today become huge when we try to make predictions at a cosmic timescale, making this system as unpredictable as the Monopoly game. What I do in my work is trying to measure, to quantify the degree of uncertainty, of unpredictability of such chaotic models, and trying to understand why some systems are more predictable than others. We build mathematical models which are abstract enough to be simple in form to study, but yet general enough to find many applications, such as in traffic networks, wireless communication, weather prediction, or even understanding how some diseases spread around the world. So the next time there is an unexpected snowstorm in Bristol, don't blame your local weatherman. Blame the mathematician trying to deal with such chaotic model. Thanks.